All right, we got most of this out of the way with the exponential growth. So this one, which is exponential decay, should be a little bit shorter video. We're going to find that it still looks like b to the x, but this time our b values are strictly between 0 and 1. Okay, it's going to change the behavior of this function. It doesn't, with exponential functions, the b can never be a negative number, can't be 0, can't be 1, but we have this space between 0 and 1 where we get one shape of the graph, and then if the b is bigger than 1, we get a slightly different shape. Okay, so this is going to look like, we're going to go with b to the power here, still again. And we're still going to be interested in what is happening way out on the left, what's happening at -1, what's happening at 0, what's happening at 1, and what is happening as we go way off to the right. Okay. And what we find in this case is that as we go off to the left, this is going to go toward infinity. B to the -1 obviously is still going to be 1 over b. B to the 0 power is still going to be 1. B to the first power is still going to be b. And b to the infinite power here, or way out on the right, this is going to head towards 0. Okay. So if we think of this in terms of, let me get my axis marked here with the important points. Here's 1, here is -1, here's +1 there. This time our b is going to be somewhere down here. I'm going to put it down there so it looks something like 1/3 or something like that maybe. There's our b, and 1/3 to the -1 is then a 3, so the 1 over b is actually going to be up here. So when the number is smaller than 1 to begin with, when we flip it over, it gets bigger than 1. So our points on the graph, -1 is going to be at 1 over b, that's way up here. At 0, we're at 1. At 1, it's at b. And we can see that shape starting to happen here. And it goes off this direction, and it shoots up really steep in that direction. So this is the shape of exponential decay. We again have a horizontal asymptote. It's the same horizontal asymptote, but this time it's happening on the positive side. So for exponential decay, we can say that as x approaches -infinity, f of x, the outputs, are getting closer and closer to positive infinity. And on this side, the end behavior as x approaches infinity or goes way out to the right on the x-axis, our outputs are going way up the positive y-axis. Okay, so that is our horizontal description, or horizontal asymptote description there. Okay. And so this is still consistent with our previous one. I want to throw one particular example in here because we often get this associated with a concept called half-life. Okay. And half-life is where you hear about exponential decay a lot. It's the amount of time that it takes something to decay into half of the amount that you have. Okay. And so that half-life tends to have a base that looks like a 1/2 to a power. If we related that with the growth rate, though, so half-life is associated with a growth rate again, not factor, growth rate of -1/2. Okay, so we're losing something, we're losing half of it in an amount of time, Very often a time up here where the t stands for the amount of the length of that half-life, if we write it like that. And so our growth factor, we said that growth factor was going to be 1 minus r, or 1 plus r. Growth factor is always 1 plus r. And in this case, the r is negative 1/2. So 1 plus negative 1/2 is equal to 1/2. So our b and our growth factor are still the same. Growth rates are negative in exponential decay situations. All right, so there is the exponential decay parent function, what it looks like in multiple representations. I'm also going to throw in here the analysis of the domain of this function. The domain, we can see that it covers everything from negative infinity to infinity on the inputs. So that's a domain of all real numbers, but the range over here is limited. We can't actually get to 0. We can describe this range as being y greater than 0, or in interval notation, the range is from 0 to infinity. We could describe it that way. Okay, so that hopefully ended up a little bit shorter than the other one because we did most of the discussion of new features on the previous one.